afternoon, everyone. Thank you for joining us for today's Tech Tuesday. I'm Tanessa Callanan, the event coordinator for the FAU Libraries, and I would like to welcome you to the first series of webinars about Arduino. Even though our buildings are closed, we hope that these webinars will continue to provide support for teaching, research, and learning. And we hope you find today's session will do just that. Today, we are welcoming the director of the FAU Libraries Information Technology Services Department. We'll be taking questions at various points during the presentation. So please type any questions that you have into the chat box. If you have any technical issues, you can also chat those in and we will try to help you out. Shortly after the conclusion of today's session, you will receive an email with a brief survey we hope you will fill out to help us plan future presentations. Now that housekeeping is out of the way, I'd like to turn it over to Mahesh, who will introduce himself and get right into the presentation.
Great, thank you, Tanessa. You can start the recording if you haven't already done so. Just switch to present mode. Hey, everybody. So welcome. I appreciate everyone joining this webinar, and I hope you learned something out of it. This is the first, as Tanessa said, out of a few that we hope to do, at least 5, depending on the interest and where we want to go. And yeah, let's get started. I'm going to actually show you what's going to, pardon me, while I switch cameras. We'll actually end up doing something like this, which is just simply to blink some LEDs by the end of this webinar. And I'll talk about the technologies we use, and we'll go from there. So again, I'm Mahesh Nilakanta. I'm the director of the ITS group for the FAU Libraries. And just to give everybody a heads up, everything here is pretty much under an Creative Commons license. So most of what I'm basing mine on is actually on an activity guide by the folks at Sparkfun. So I think it's only fair that whatever I do, I give back to the community. And I'll have all of this stuff on GitHub. You'll get the link for that to my GitHub page where you can download all this, including code as we build it. So you can learn from there as well. And as Nessa said, if you have questions, you can write those into the Q&A section, and you can question, and we will have a Q&A at the end as well. So myself, I work in the FAU Libraries in the IT group over there. I started actually at the libraries just a few months ago, about 9 months ago, and before that, I was over at the College of Engineering for about 13 years. And the reason I moved over actually is the libraries actually do some really cool stuff with technology. There's a lot of initiatives that Dean Hickson is looking at, and a lot of that involves technology, both some things as very basic as coding to bigger things like AI or machine learning or cloud computing. If you haven't attended it, there is a recording of it. We did one on 3D printing and hope to do so some more in the near future. Minor housekeeping, you're all in webinar mode, so you don't get to show your videos. You are all muted, and we can unmute you if needed, but like we said, the chat is available. And there's also an option to raise your hand, though I have never used that, so if you do plan to use that and I ignore you, just switch to chat mode. I am testing out a polling software that I found in another webinar I attended, so I'll be doing that shortly, and I hope you guys try it out. Let me see how it works. And as I mentioned, the slides and documentation will be available on GitHub for you. And this presentation itself and the link to this will be provided through email afterwards. So let's just get started. Our goal is to try a demo. I'll talk quickly about how the series is organized. I'll talk about Arduino and what you can do with it. If you haven't gotten it, you can get one of these things. This is actually what we're going to use. It's called the Tinker Kit by a company called Sparkfun, which has all kinds of hobby electronics and things like that. And we'll be using this for the entire series. And then we'll definitely get the software installed and see how it is to blink an LED. Very simple stuff, but I hope that you'll learn something from it and see how easy it is to do it. And then we'll talk about the next module that we'll be doing and do some Q&A. So what you see here, let me switch my camera over, is a blinking LED. And over here, I'm actually going to stop my presentation so that you can see the see it in a bigger screen. Hopefully you can see it in a bigger screen. And over here is the actual Arduino itself. And we have a couple of blinking LEDs. This happens to be blinking 2 different LEDs in sequential order, going on and off, on and off. And all of that is done with very simple code. And if you haven't programmed before, I'll show you how that works and how simple that code looks. Give me a second while I switch back to presentation mode. So this is basically a screenshot of that I took yesterday. The code to do that, that's pretty much it. All we have to do is simply, second. Share my screen again. I'm actually going to stay in this mode so I can switch screens quickly. The code to do that is actually right here. We just turn on a couple of output pins, which basically send electricity out, and then we turn them on or off and wait a second and turn them in the opposite order, on or off, and then wait another second. And all this is done, uploaded into this little piece, this device called an Arduino Uno, and just lets it run. So at the end of this, we'll be able to do that. And if you have the Tinker Kit, you'll be able to build that as well. So what will we cover throughout the entire series? As I mentioned, we're using the Tinker Kit, and we'll be using their activity guide. They actually built something. So all of this course is actually built on their activity guide. And we'll do it over a period of about 5 to 6 sessions. And let me just bring up my chat window so I have that. This will be recorded. Somebody had asked. So yes, it will be recorded. Or it is being recorded and you can play it back. I'm not exactly sure how many sessions we'll be doing. It really depends on how fast we go. Easily, it'll be 5 to 6 sessions. And I plan to do this every other week because of other obligations. And that'll also give you enough time to order one if you don't have one and play around with it. And some contact information will be at the end as well. So if you have questions, you can always email me. We'll be doing 1 to 2 circuits from the guide every week. And I hope to do next week's session just a real quick thing on how to program on Arduino, and then we'll be able to continue with the circuits, continue building circuits. This is a beginner course, so you're not really expected to know much, but at the end of the series, we'll see if there is interest and we'll do more advanced courses like using Wi-Fi so you can connect out to the internet, and even things like connecting to the cloud and sending information out into the cloud. I have these kinds of devices, more advanced versions that actually send my pool temperature and stuff into the cloud. And right now, I'm looking at doing this twice a month. So I won't be doing the survey just based on my own schedule. Unfortunately, that's about the only pace that we can keep it at. So what is an Arduino? So as I mentioned, it's really just this device right here. It's called a microcontroller, and it basically has a CPU, some code that's running, as well as these little things that are right here are little pin outs that you can actually control devices like an LED. These wires over here carry electricity to turn an LED on and off. An LED is a light emitting diode. It's basically like a light bulb that's polarized, so you can only turn it on when you send electricity in one direction. The really cool thing about Arduinos is that they allow you to program very, very easily and very, very cheaply. The cost of this device that you see right here is actually, if you buy it from Arduino, is about 20 bucks. But you can get it as cheap as $4, and I'll show you some of the options that are available. Maybe before the Arduino, devices like this used to cost anywhere from $50 to $100. And so if you did make a mistake, it would be a very expensive mistake. So to get into it as a hobbyist or a experimenter or a tinkerer or a maker, whatever you call yourself, the ability to do this very cheaply is one of the great enticements of the Arduino environment. The hardware itself is actually open source. In fact, you'll see a lot of clones for Arduinos, and it's perfectly normal. If you ever buy online on Amazon, if you search on Amazon for Arduino, you'll actually see a lot of third-party manufacturers who've made Arduino clones. They also come with a really rich ecosystem of shields, and shields are these devices. Here is a shield I'm going to put underneath here. This is a shield that's actually an LCD display. If I look underneath it, you'll see these little pin connections right here. These actually plug on top of the Arduino. So if I wanted to make something with a little LCD display, I can do that. This is a shield that actually lets me build other circuits on top of it, so I can prototype other devices. This one is a shield that allows me to turn on and off switches. So I can actually turn and off electrical devices like the equivalent of a power switch to turn on a light, for example, or a motor. So it uses an actual relay inside of it. These shields go anywhere from $10 to $500, depending on what it's doing. Most devices are in the $5 to $50 range, most of those shields. The way you program it is using something that looks like a language called C. There are other languages as well. There's something called Blockly, which I'll show you in just a bit. And some of the higher end Python units actually allow you to program, higher level Arduino units allow you to program it in a programming language called Python, which some people find a lot easier to program with. And in this session, we'll actually be installing the Arduino IDE, but there's another system called Blockly, which I put a link here, as well as an environment from the folks at AutoCAD called TinkerCAD, which lets you build circuits as well. As I mentioned, the hardware is open source. The unit that you see here, this unit right here, is actually a clone. This actually cost $4. It's the one that you see generic from China on my list. I just used that because in case I burnt something out while building this, I wouldn't be crying over spending $23. But there are slightly more expensive clones. This one is about $12 that I got on Amazon. And the one that comes from Sparkfun is actually around $20. The original Arduino board that's actually made by the folks at Arduino is this device. And you can see it's actually the build quality, you can't tell from here, is actually very good. It has a little electrical sort of plastic panel to prevent it from accidentally short-circuiting devices and stuff. So these devices vary in prices. I highly recommend getting something from Sparkfun or even the Arduino. But if you're going to be doing a lot of experimenting, definitely look at the ones from Chinese websites like AliExpress or Banggood, for example. Those are two great sites. Lastly, there are other versions of the Arduino. Over here, I've actually made a list of a whole bunch of different ones that are out there. The one that I'm going to put underneath here, this is actually called the Arduino Mega. If you look at it, this actually is a bigger board. It still has the CPU in the middle, but it has a lot more pins and has more connections as well to connect to higher end shields. Just a second. So what can you do? And this is actually going to be a question for folks to answer. So I'm actually going to paste it in there. If you can look in your chat window, there should be a link there, or you can type this thing in there. You can learn to code. It's a little bit different coding on an Arduino. It's not like programming on your computer or programming a website or programming an app on your mobile device. This is really very physical, right? So you're actually interacting with something that's directly in front of you. It's very experiential. And the ability to experiment and build and learn about electronics and circuits is one of the reasons why a lot of people get into it. You can build all kinds of devices with sensors, displays. You can check temperature, humidity. You can turn switches on and off. You can play music. You can make motors move. One of the reasons I actually like continuing to do this is it's a way for me to bond with my kids. I'm slowly teaching them about electronics very organically and experientially. And now they're starting to ask questions as to how can I turn things on and off, or how can I make the motor go faster or slower? And that's where programming comes into play. There's this whole wide world called IoT, Internet of Things. And if you ever use any home automation like Google Nest or Ring or Amazon Alexa, those kinds of devices, all of those use this kind of technology behind the scenes. So I'm curious, why are you here? So if you click on that link, I actually have the answers. If I start my meeting, you can go in there and try and click on your option. I should technically see your answers crop up here. So let's see if anyone is able to select anything. If you don't, it's okay. It means I made a mistake. Oh, maybe I have to click start. There we go. Let's try that again. Oh, I got one answer. Okay, there we go. It was really cool when I saw the other webinar. There were 100, I think 1,300 participants. So this thing was going all over the place. So I think most of you can see the answers as they're coming in. Cool, we got 17 answers. So great. So as you can see, wow, it's evenly sort of distributed. Everyone except nobody wants to bond with your kids. Okay, all right. That's interesting. I guess it's just me then. So go there and let me stop this. All right, I guess I can leave it running, but. And let's take a look at the actual Sparkfun Tinker Kit itself. So I'm going to move this out of the way temporarily. And if you have the box, you're welcome. You probably already opened it and looked all through it. But the box itself is pretty small. It's not that big. But it comes with a whole bunch of cool stuff. Some of these things you may already know. For example, this is a USB cable. This is actually what lets you program the Arduino and connects it up to your computer. This is it's called the red board right there. That's the actual Arduino. It's red, so that's why they call it the red board. But it's an Arduino Uno, and it's made by Sparkfun. It's because the hardware is open source. They built it themselves. You have something called a breadboard. This is actually where we'll be building our circuits on. And I put some links in this presentation that you can read about and how a breadboard looks and how it operates. This is where we're going to prototype our circuits. There's all kinds of other cool stuff. For example, this is an actual, let me take it out of here. It's called a servo. If any of you have ever liked radio controlled cars or anything like that, this is the device that actually lets you turn the steering wheel or steering mechanism in radio controlled cars. Used in all kinds of other stuff too. But we get a whole bunch of LEDs. They give you a lot because you burn through LEDs by accident. You get some motors, and these are really cool because you can basically drive a motor using the Arduino, and you can even technically, if you do it right, connect these up to Lego kits, which is something a lot of hobbyists do. A whole bunch of buttons and sensors, and we'll be using this in the later classes. Some things called resistors. These control the flow of electricity. More resistors. This is a battery pack. You don't get the batteries. I put my own batteries in there because you can technically run the Arduino without connecting to your computer. So after you've programmed it, you can connect it up to a battery pack like this and then run it independent of your computer. And then you get these things called jumper wires. The jumper wires, as you'll see back when we go back to the kit, are what you use to connect up the Arduino to the devices that you're programming. And that's pretty much it, except for this little guy here. This is an actual, it's kind of like a shield, but it stands alone by itself. It's called a motor driver. So this is actually what will be used to control the motors, that those two yellow motors that you got in the kit. The kit itself, if you haven't gotten it, it's about $49. So it is not cheap, but you do learn a lot from it. And it does help Sparkfun do a lot of really cool other projects. If you don't want to buy it, that's perfectly fine. I'll be going through each of those circuits in this class, so you can learn with me or experiment with me. Give me just a minute while I plug this back in. So as you can see over here, we'll be building, I'm actually going to take the circuit apart right now. These are the jumper wires. These are the resistors. These are the LEDs. And we're connected all of those up together. And I'm actually going to turn the power off. Try and turn power off before you work on these devices. I'm just going to leave those plugged in so I don't have to reconnect them. And over here on the screen, you see all the different types of devices that you do get on the project, on the with the kit. So the next step is actually downloading and installing the software. Now, I happen to be doing this on a Mac, but I know most of you probably use Windows. So I have a Windows box over here. And what I did was, let me bring it up over here. If you go to arduino.cc, you can click on Software, Downloads, and you can go over here and download the installer, obviously whatever operating system you want to run on. The current version is 1.8.13. They do update the software pretty frequently. So if you, it's very common for you to this last number to change. It is worth keeping up to date on it. It can download it automatically, but installing it goes through the standard install process. And that's actually what I'm going to do here on the Windows system. So go through the process. Now, the installing process, I'm actually going to show this on my screen. You'll see all kinds of weird questions like, would you like to install this driver software? You might get a Java warning. Since you're connecting to an embedded device, there are some additional drivers that are installed as part of the Arduino installation process. Now, I already installed this once on this Windows machine, so you may not see that message, but it is perfectly normal to get those kinds of messages. One is the Arduino development environment is written in Java, so that's why you have to accept the Java warning. And the other is, in order to connect to your Arduino Uno board, you have to install some drivers so that it can talk through the USB port. So it's still going through the installation process. I'm going to let that run and jump back over here. There are two other packages that are available. One is programming using the web-based interface. And so if you're not interested in installing something on your computer, you can program the Arduino using a completely web-based environment. And it's called create.arduino.cc. Now, it is free, but they do have paid subscription plans that let you do more advanced stuff. So it's a great way to get into it without installing too much, though it does need to still install a device driver on the system. So let me connect this to my Mac.
Hey, Mahesh, we just have one quick question. Someone wants to know if they can make their own software for the Arduino.
Absolutely. Well, software, can you clarify what kind of software? Software like turning on LEDs and rotating motors and taking temperatures? Yes. Software like a Windows application that can, you know, like Microsoft Word or something like that? No, the Arduino is not capable of doing it. It's more like building electronic circuits and programming those circuits to do certain things. Let me know if that clarified the answer question.
Yes, it did, Mahesh. Thank you.
Okay, great. I am just going to, it's a good question. I showed you this earlier, which is the Arduino Mega, slightly more powerful. But right next to it, some of you may recognize this. This is called a Raspberry Pi. In one of the more advanced classes, if there's enough interest, we'll jump into this. This is a full-fledged computer. It actually runs an operating system, happens to be Linux, and it has a HDMI output. It has an Ethernet port, I can barely see it, and it has USB ports. Sorry, trying to play with the camera here. This is a full-fledged mini computer for, I think right now the going rate is $35. This can actually run web browsers and all kinds of other stuff. But it's in a whole different ball game altogether. It's also more expensive, so if you burn that out, you cry more. So it's cheaper to burn through $4. All right, switching back. There's also a software simulator, which I'll show you right at the end. And there are all different ways to do the coding. In our class, I'm primarily going to focus on using the Arduino environment, because part of what I want to have people experience is the ability to run the Arduino Integrated Development Environment, IDE, and really get experience with this, because a lot of the real, as you become more and more advanced, you have to be able to work in this environment. So the installer finished, and if you noticed, they didn't ask me for those driver questions because I had already installed it before. So when you install it, you'll get a prompt like this on your machine, and if you double click on it, it'll start off in this mode. I'm not going to wait on you just because I need to finish the presentation, but if you want to run this in the background and run through the installer, you can, or you can do this after the class and then come back and we can, and then email me if you have any questions or issues with the installer. If you're on a Mac, it's very similar. You just drag and drop the application into your applications folder and then start it up that way. If you're on Linux, it's a lot more complicated, more advanced than we have time for in this class. So we've got the IDE. Now what we want to do is actually Blinkin LED. I put some links, and I said, as I mentioned, we'll send you the link to this presentation. There's really great presentation talks about what is a breadboard and how to use it. So if you take this link and if you scroll down, it talks about what a breadboard is. It literally is kind of called like a breadboard, like because it's like bread. You stick things in it too. That's an example of a slightly wider breadboard like what I have. And there's also a quick talk about what the breadboard is, which is the Arduino Uno that's made by Sparkfun, as well as the Blinkin LED. So we're actually going to use the first circuit on Blinkin LED. And the first step in that is actually building give me a second, is actually building the circuit itself. So I'm going to actually click on this link and go over here. And this is why I really like this activity guide. Everything I'm doing here is pretty much taught right here. So on the right-hand side of the activity guide is the actual introduction. We kind of actually did a few of this. And then each of the circuits has its own section. So the next one we'll actually be doing is the potentiometer and then the photoresistor. But today we're going to do Blinkin LED. Here's the end product right there. And so you can see the Arduino Uno and then the breadboard, 2 wires connecting up, and then a resistor. It even tells you what the purpose of the resistor is and how to read it. There's a chart and a little bit about electricity in here. But our goal is to actually build it. As I told you, the LED is a light emitting diode. It's polarized, meaning you can only send electricity in one direction in order for the diode that's in there to light up. The resistor is there actually to protect the LED from blowing out in case we send too much electricity. And down here is an actual visual circuit diagram. So they actually built it using this software called Fritzing, which is a really great way to diagram out things when you're trying to prototype your designs. So I'm going to basically move my screen, and then we're going to build this on my screen. Actually, I actually have Zoom running, so I'll actually use this. Let's try this out. Hey, Tanessa, can you tell me if you can see the video?
Yes.
Okay. Is it clear enough? Can you kind of see that?
Yeah, it's clear.
Yeah. Okay, great. All right. So I didn't plan to do it this way, but I'm going to try it out because I like experimenting. I actually was using Zoom because Zoom has a really nice feature where you can run a Zoom meeting, which it's actually been running for the past 42 minutes. But I love it because I can actually use it as a screen to see what I'm doing. On my Mac, I don't really have a thing to show my webcam. So I completely forgot I had it running. So over here is my circuit. And I'm actually going to follow the instructions and wire this up. So here is my Arduino Uno, and there, as I mentioned, there are a whole bunch of things in here. There's the central processing unit. This one has the code for Arduino itself, the firmware for it. We have some ports here. There are digital ports, analog ports over here. It actually says analog. There's power to send electricity. And over here are additional ports to do all kinds of input-output stuff over here. There's a LED that's blinking that says that everything is good. It happens to also be connected to pin 13, which we'll see why in just a minute. There's a little transmit and receive LED over here, which blinks when you're uploading code to it. Over here, a little bit down here, is an actual USB port. This is how I connect my computer. I'm going to bring the, most of you know what USB is. Here's the USB port for the red board. You can see that this is different. Different manufacturers decided that they're going to use different types of ports. This is the one that's on an actual Arduino. You can see that that USB is different. This is the USB that you see mostly connecting to printers. They're just different form factors. The reason that Sparkfun decided to use this one is it's actually smaller and easier to work with than the ones that the original Arduino folks did.
Mahesh, sorry to interrupt. I just wanted to let you know that the Zoom video, it lags a little bit behind your live.
Okay. So then let me go ahead and stop the Zoom and I'll switch the video to that. No, that's great. Let me cancel that. This is not ending our meeting, so don't worry, folks. All right. And then let me stop my presentation. I think that should hopefully maximize my video. Okay, did my video max become bigger?
Yes.
Okay, cool. All right, so let's finish building this circuit. So if you go to the website, you'll actually see the circuit. I happen to have it on my other screen. So the first thing they tell you to do is basically wire up pin 13, which is right here, pin 13, to the breadboard. And it doesn't matter where in the breadboard it is. So I'm going to go ahead and connect up my pin 13. And you kind of have to make sure you connect up things right. If you're off by just a little bit, it won't work. And then the next thing you have to do is connect up a resistor on that same line over, and then connect up the LEDs. Now, the important thing about the LEDs, I mentioned this in the tutorial, there are two types of LEDs here. There's the positive and the negative. And if you don't do it right, the positive is the longer one. If you don't do it right, it won't light up. So I'm going to go ahead and connect this up over there. The last thing to do is to connect up the ground. And so I'm going to take another wire, connect this up. And if you know anything about circuits, the reason it's called a circuit is literally it's a loop. And so like a circuit, like a car circuit or anything like that, you have to close the loop. And so I'm bringing that back up and I'm going to connect it to ground. And I happen to already be running the code, and that's why it already started blinking. Now, the other two are going to be there in just a minute, and I'll explain why in just a second. So I'm going to stop, switch to presenting my screen again. Give me just a minute while I find my So that copies into your buffer, your clipboard. And then I happen to have Arduino already on my Mac, and I am going to File, New. And I'm going to just paste it in there. I'm just going to get rid of this just so it's easier to focus on what we see over here. So this is the code. Most Arduino codes has two sections. One is called setup, which basically configures the hardware. And the other is called loop, which is what the board will do in a basically called an infinite loop. It'll keep running this for as long as you leave power running on the board. So the first thing, as you remember, we connected to pin 13. And what this does is it says, hey, instead of configure this pin to send electricity out. In other words, go in output mode. Input means read a value. So for example, if you're reading temperatures and things like that, you would get data and you'd configure this for input mode. And that's all we're configuring it for. And then it goes into loop. And so this section keeps running forever as a loop, literally a loop. And it says, turn on the LED. So this says send electricity. By turning it high, you're sending electricity through that pin. Now the electricity I'm talking about isn't the same power as your household electricity, 110 volt. It's DC voltage. So it's anywhere between 3 and 5 volts. So a little bit more than what you would get from a AA battery. Then it says wait for 2000 milliseconds, which is 2 seconds. Then turn it off and then wait for 2 seconds. So when you have your code, I happen to already have this configured, but I'm going to just show you this section again. You have to make sure that you connect to the right port. So in mine, the port is called USB modem 1430, whatever it is called on my Mac. On your PCs, it'll most likely show up as a COM1, COM2, COM3, COM4, like that. So once I have it configured, I also need to make sure that my board is set to an Arduino Uno, which is basically right here, Arduino Uno. And then to upload the code, this is actually going to compile. I'm going to not save my code. It's actually going to show what it's doing over here. And it's actually uploaded the code onto my chip. And if you look carefully, while I was uploading it, I'm going to do it again. Have a look at my video. You'll see the blue light blink really fast. And do it again. And cancel. Watch very carefully. There. If you saw it, it blinked really fast. That's when it was actually uploading the code. And so this is turning on and off every 2000 milliseconds or 2 seconds. Just to make sure that I'm not lying, I'm going to drop this down to 500 milliseconds, which is half a second. 500 seconds. I'm going to hit play. Now we should see it blink more frequently. There it is. If you look carefully, it's blinking at a higher frequency. This ability to modify code, upload it, try again is one of the greatest features of the Arduino IDE and the Arduino environment. You don't go through an entire process of compiling, uploading, debugging in a very complicated environment. For example, if you're programming in Windows under Visual Studio or Xcode on a Mac, there's very immediate feedback. And it's one of the nicest things about programming with these devices. And it's literally turning a LED light on and off. So you have very nice feedback to what you're doing. Now, I'm just going to show you how easy it is. I happen to already have connected another wire, another LED up here, but I haven't wired it up. So what I'm going to do is I'm going to take pin 12, which is right next to 13, connect it up in a very similar fashion. There happens to be 2 grounds. And if you don't know what ground is, that's okay. We'll go through that stuff in a future electronics training, but you can also read about it. Connect it up over here. And I've wired it up, but nothing's happening. That's because I haven't programmed it to do anything on pin 12. So I'm going to take this code and paste it here. And for now, I'm just going to say pin 12, pin 12. Let's see if it works. You know what they say about live demos, right? Now, technically, it should bring both LEDs on and off, and there they go. And you could do silly things like low and high. So I'll do the opposite. Now they should blink in opposite order. On, off, on, off. So this ability to kind of experiment and tinker, like I said, is a really powerful feature of the Arduino environment. And they go through the same steps over here again. And so they can tell you a little, in the example, they actually give you a little bit more about what it is. I'll be going over more of how the Arduino C language works in the next session. But again, you don't really need to know much in order to get going. You can tinker with this. You're not really going to, you know, burn down your house by playing with this stuff. So very safe. So we did a few different tests. So this came out a couple of years ago, maybe a year or two ago. And basically, the folks at AutoCAD who bought TinkerCAD said, hey, how about we actually create a simulator? Let's actually do the exact same thing, but rather than doing any hardware, you can actually build this on your browser and run the simulation. And on top of that, let's make it really easy for people to write code who don't know how to write code by using block programming. Some of you with kids may know things like Scratch and a few other environments that do this coding by blocks. And so TinkerCAD is a program that lets you do that. And I actually already have it loaded over here. And so what I have here is a simulated Arduino Uno. And if you look, it looks very similar to the board that's on my video screen. I have the same kind of pinout. Here's an LED. Here's the ground. Here's pin 13. All right. In this case, they're using this ground rather than this ground, but it's perfectly fine. They happen to have grounds all over the place because you use ground a lot. And they created a small piece of code that's done using what's called block programming. And so for this is especially important for kids who are learning. It's much easier. You basically drag and drop these pieces together and they click in and you can write this code. The cool thing about this is you can actually look at the code that this generates. And if you look very carefully, it's almost exactly the same as the code that we did. Now, what's great about this is that you actually don't need an Arduino Uno to run this. So I'm going to just put that off. And I'm going to click Start Simulation. And if you look carefully, this little LED is actually blinking on and off every second. Now, this has nothing to do with the Arduino that I have plugged into my computer. This is purely running as a simulation in the web browser. So if you want to get started and don't want to buy anything and just want to play with Arduino programming and don't want to worry about short-circuiting something or burning something out, TinkerCAD is a great way to do this. If you guys had attended the 3D printing class, we were also using TinkerCAD, and Crystal from ITS, it's owned by AutoCAD. She used this tool to actually build the 3D models. So they just happen to also do circuit design as well. AutoCAD's trying to do a lot. So I have included a couple of links in the presentation on, again, what is Arduino? This is, and as well as an introduction by the folks who actually made the Arduino. They're actually a company, a nonprofit based in Italy. And as well as what exactly is a circuit and how does all that fit in together. There is another real brief introduction on electronics. This is basically telling you about, what voltage is, what amps are, watts are, and all those things. You don't need to know all those things to just play with the basics of Arduino, but it does help as you become more and more advanced. For example, I built a pool sensor, and it was very important for me to run it by solar power and pool temperature sensor. and I needed to make sure that the battery I used could be charged by solar panels. And so I had to measure the amount of current that the solar panel can generate. So that's when you start doing more advanced stuff. It helps a lot. So for the next module, which will be in 2 weeks, we'll be talking about the Arduino C programming language, and also extending the blinking LEDs to use more advanced language things, language syntax like if statements and loops within the if statements based on like pressing a button or something like that. So you can understand how the language will help us for the more advanced classes. So real quick, if you have questions, here's my FAU email right there. But I would prefer if you could send your questions to libticket@fau.edu, simply because it allows us to. This is our internal ticket system at the library. We're creating a special queue just so I can track the questions from here. I get a lot of regular emails as well, and so I don't want to accidentally lose track of a question that you may have for the class. And so if you could please send it there. If you have just a general question that's unrelated to the class, like maybe future classes or something like that, I'll be happy to answer it. But in general, I prefer if you could send it to libticket@fau.edu. And over here, you'll be getting this link. This is my page on GitHub. Right now, in there is the actual code for blinking the 2 LEDs that we wrote. But as the class progresses, I'll be uploading more and more code as we finish it, so that you can always go to this GitHub page and download it for yourself if your version doesn't work. I'll also be updating the slides as we build them for this presentation, and the current slides will be uploaded there by the end of the day. And that brings us to our conclusion. So let me go to chat. And if you have any questions, I'll be happy to answer them. Tanessa, is that in the chat window or in the?
It's in the chat window right now. There are any additional questions? Looks like you touched on them while you spoke.
Oh, okay, cool.
So
all right, guys.
Also, paste the GitHub link into the chat box just in case anyone wanted to take a quick look at it.
Yeah, absolutely. Give me a second. There you go.
Thank you, Mahesh. And we just want to thank everyone again for joining us, and a special thank you to you, Mahesh, for putting together this presentation. We just got another question asking if we'll send all the links. Yes, we will send all the links to your email. You'll actually get a link with a brief survey, and in that email, it will also have the links to our YouTube page where we will upload the recording from this session, and I will also include all of the links that Mahesh spoke about today.
Yep, real quick, we included the link for the Tinker Kit, so it's also on this. It's this product right here. It's called the Sparkfun Tinker Kit, which is basically the items that we looked at. So, yep. All right, everybody.
Getting a lot of positive feedback, Mahesh. So I just want to let all of the attendees know that we will also keep in touch with you all for session number 2. Yep,
we will. Thanks again. And yeah, please, feedback is important. So if we're going in the right direction, too fast, too slow, obviously, I know this stuff already, but I want to make sure I pace it at a level that's useful to you.
Mahesh, we are getting questions about the date for the next session.
Oh yeah, so we will be doing it every 2 weeks. So the next one will be 2 weeks hence the 28th.
Perfect.
And then 2 weeks after that. And so in between that, obviously, please email libticket@fau.edu, and I'll be happy to answer questions. If you order the kit, build the first kit by yourself, download and install the software, and play around with that. For those of you who are not buying it, feel free to use the TinkerCAD to run the simulation. You can literally do this after the presentation. Just go to tinkercad.com. I'll paste that in the chat as well. And then there's, of course, the web-based editor, but you still need an Arduino to use that. So.
Perfect. Well, thank you so much, everyone. Stay safe and enjoy the rest of your week.
Bye, guys.